Hey guys, welcome to this lecture for Intro to Backend Development. This week we're going to be talking about images. So a lot of your apps are going to need images. Oftentimes you might take user uploads. So for example, if a user wants to change their profile picture, they're going to have to upload an image and you're going to have to store that image somewhere. As Hack Challenge is approaching, we've decided to include this optional lecture for those of you who want to use images in your backend. And hopefully this will be of some use. Elena's demo will talk a bit about how more practically you can do this, while this lecture will explain sort of why we decided to use the system that we're going to teach you. All right, so let's talk a bit about storing data. So far we've taught you guys about how to store data in our relational databases. In each table, we have columns which all have types. This is one of the advantages of relational databases in that all the data is structured. So in our example table here, with probably some fruit inventory, we can see in SQLite, if you check the type of the column, it's going to look something like this. ID is going to be an integer column. Your name is going to be some sort of text. And then like a price, since it's a float, it's going to be some sort of real value. But it's not immediately clear how you're going to put a column type to an image. What if we want a little thumbnail for each one of our fruits, as we have here? How are we actually saving that data? So how should we store images? I'm going to go through 3 ways that we can store images and explain why some of them are better than others. So first, we can actually store the image in the database as a blob, which I will explain. Then we can store the image local file path in the database. And finally, we can store the image URL in the database. So let's talk about storing blobs. All right, what is a blob? So think of a blob as a blob of data, which is stored exactly how it was inputted. So essentially, it stands for binary large object. That's where blob comes from. And it's just a collection of binary data. So where are we actually using this binary data? This is used in documents, images, which we're talking about now, and other multimedia files. So what happens if you try to print a blob, right? What happens if you try to print raw binary data? It's going to look like this. In fact, sometimes if you've ever attempted to, you can actually go on your terminal right now and do like cat, which will sort of echo the contents of a file, and then like any picture in your system, it's going to give you a bunch of nonsense. And that's because the system is trying to display binary data as an encoded string, whether it's ASCII or it's Unicode. So that's why you see all these crazy symbols, because you're trying to decode this binary data, which isn't encoded at all. So it's just going to spew nonsense out. It's kind of scary, but that's kind of what it looks like. And this is just a snippet of what happens if you try to print out a blob. Usually blobs are massive. In fact, I had to delete a lot of lines from this when I printed out the contents of even a very, very small image. So technically, we could create a column in our database that's type blob. SQLite does support blobs. You can store the information in there, but it's an idea. So why? So first, database storage is relatively expensive. Again, blobs are extremely large. Your average screenshot is about 150 kilobytes. And compared to that, your average string is far less than 1 kilobyte, and integers just like 1. So you're going to be using up a lot of space in your database. Secondly, and probably the most compelling reason, is that databases are designed for structured data. That's the whole reason why we're using relational databases. So relational databases are going to use all sorts of techniques to try to speed transactions up, such as indexing. But you can't do that with blobs. You can't index blobs. In fact, you can't really do anything with blobs besides just store them and load them. So for example, if you try to do like select, how do you select some property of a blob? There's nothing that you can really know about a blob besides that it's just binary data. So you would end up allocating a lot of unnecessary memory on your server client. when they're querying these images. It's going to be really slow. And backing up a database with blobs is slow. Again, these take up a lot of space. It's just going to be annoying, especially if you're backing up your databases frequently. So for example, like every night, if you have like a terabyte of images in your database, that's going to make backing up way, way, way slower. All right, so why don't we try a different technique? Why don't we store the file paths of the image? So let's just have a quick reminder that servers are computers. Even when you deploy your code to a remote server, that is also a computer, just handled by some other third party, like Google. So data, of course, can exist outside of just your code and your database. And images are files, and your server and most computers have file systems. So why not just save the image on your server, right, in the file system, and then have some sort of reference to that image, aka a file path? So what we can do in our servers is, given a static upload folder that we allocate on our server, we can create a post route if someone wants to upload an image that can access the request.file. So if you remember, you often use request.data. There's also another field called request.files, just for files when you upload HTML. And it will save the image to your server. So let's say that in our server, we have our root directory, and in that we have our source code for our server. But then we also have another folder called images. And you can just specify that whenever a user uploads an image, then it will go into the root/images folder and just live there forever. So that's really convenient, right? Then your table is going to look a lot cleaner. Instead of saving an image as a blob, a column, we can now save just the image path, which is just going to be some string, right? It's going to be images/filename.extension. So let's talk about advantages of the file paths. We can avoid some slowness with the database storage. In fact, it's really easy to parallelize retrieving file data, as the database isn't bogged down making a query for a massive image. So you can imagine, like, if you're trying to make a query for like all images saved in your database and you have a ton of images, then your database is going to be available for making another query. Next, file stores are much easier to scale than like database sizes. So disk storage is really cheap. All you have to do is add more storage if you're running this on a physical computer, or you can just add more dedicated file servers. So you can have servers just for holding image files, and those are much easier to scale than databases. Also, if you save your image as like an actual image file instead of just like a mass of binary data, the server doesn't need any special coding or processing to access those image files. So for example, if you want to take a look at what's been uploaded to your database, hopefully this doesn't break any privacy that you are trying to guarantee. But like, if you wanted to check out like, oh, what have people been uploading? Like, I want to take a look. You could just go into the file system and look at those images instead of, well, if you try to retrieve that image from the database and once you query the raw data, you have to convert that back to a file. It's not saved as a file, it's saved as binary data. So that way you don't need that middleman conversion of binary data to an image file. Finally, image backup is asynchronous. So asynchronous to your database backup. If your database backup has to happen really frequently, but your file, like image backup, doesn't have to happen that frequently or takes a long time, it can be offloaded to some other machine for backup, and your database is free to continue making queries. And file paths are prettier. It's a lot easier to see when you're looking in your database. Okay, so we're talking about saving our images to our local server computer. So this could mean that you are saving it to your actual computer that's running a server, which probably isn't happening. Or you might be saving it to another remote server, which is probably what's happening. If you're deploying to Heroku or with Google Cloud or anything, it's going to be hosted on one of their machines. But what if you want to, save those files elsewhere, somewhere that might be a little bit safer and easier to scale? Um, so you might want, oops, that's a typo. You might not want to store large volumes of images locally. So if people are uploading images and it's all being saved on your computer, that might fill up pretty quickly. Next, you might not be able to access your files if you spin up another server. So what I'm saying here is that if you have all your image files on one server, and then you're like, all right, well, now we have more volume coming in terms of requests, so let me just spin up another server to load balance those. Well, now that other server doesn't actually have access to the files in the first server. That could be a huge problem. And you might not want to handle your server crashes resulting in users not being able to access their files. So when your server goes down, that's where the files are too. So what are you going to do with those files? What if people need to access them? You can't, pretty much. And in general, you might want to separate responsibilities. So keeping your files, if you want somewhere else to host your files instead of your web server, which is primarily for serving your website or serving your web app, then that's a pretty reasonable thing to do. All right, so let's talk about cloud-based storage. In this class, we really advocate for cloud-based anything because there are these companies that have like a bajillion employees who are going to build a very robust infrastructure for your servers and for your storage, which is really nice because you don't really have to depend on the limitations of your own machines. So there are free and paid services that offer remote file storage. Just to name a few, we have Amazon S3, Microsoft Azure Blob Storage. You can see the word blob there again. This is really just multimedia storage, object storage. And then we have Google Cloud Storage. So all of these, plus many more, there are so many services that allow this. It's just infrastructure that supports strong scalability, meaning that you can, if your app grows from like 5 users to 50,000 users overnight, they can handle that influx of images coming in. It supports strong availability. So that just means that if things go down, they have practices in place to help make sure that your data is safe, it's not lost forever, and it's back up really quickly. And security, of course. And now what we're doing, instead of storing local file paths in our database, is storing a URL to the file that's hosted by, for example, Amazon S3, which you will see in the demo. So that's really convenient. It's going to look like a pretty normal URL that you can access, and it will bring you directly to the file. So again, this is going to be a lot more robust than anything we're making, unless if you want to make a better solution, then in that case, I guess be my guest. All right, so I'm going to talk a bit about the demo. This is an example on how to store and retrieve images with Amazon S3 within your server. So your clients are going to upload images encoded as base64, which is just an encoding from binary to text in your requests. Then, as a response, they're going to retrieve an Amazon S3 URL, and it's going to look something like http mybucket.s3.com. It's a URL, and this is actually what you'd be saving in your database as well. And there are a lot of alternatives that you can explore, but we hope that this demo is straightforward enough for you guys to use in your own hack challenges. Good luck.